Okay, so hold on to your seats. This is the second part of these videos, talking about the definition of the slope. So first of all, here is the algebraic definition of the slope of a curve using calculus. It's in terms of limits, which we already learned. The slope of a curve of a function at some point p. So you notice you have to have an x value. So this could easily be x and the f of x. Doesn't matter. Okay, instead we use a, f of a. It's just a variable, don't get confused. Is the number the slope? Remember, m represents slope. And the limit as h approaches 0, we're going to talk about what h is. Okay, because it's a number that represents more of an idea than a number, really. Because h is a number as close to 0 as possible with ever actually being 0. Alright, so it's f of a plus h minus f of a all over h, provided the limit does exist. And later on we're going to talk about when the limit does, when the limit doesn't exist, stuff like that. So definitions, we talked about a tangent line. It's what we talked about just there, that little green line, remember? The tangent line to the curve P is a line through P with the slope. And the normal line is a curve at P, and it's perpendicular to the tangent line. So if we go back here, okay, the green line is your tangent line, and then if we were to do a normal line, it would be whoops, man, that's beautiful. It would be a 90-degree angle to that tangent line. So the blue line, this is your normal line. Okay, it's perpendicular. That's it. Normal lines aren't difficult at all to find if you can find the tangent line. Those are the hard ones. Okay, so now the definition, we're going to come up with where this came from, because this is really important to understand where it came from, because it's going to help you conceptually, not necessarily to use it or when to use it, but it's going to help you conceptualize a lot of these problems in the homework, the tests, the quizzes on the AP exam. So we start with a graph. The graph had a baby. That baby grew up to become a function. Now, you notice this function, this baby, at every single point on its domain, it changes slope at every single point. All right, so if we looked at this point, this point, this point, this point, and we drew tangent lines, so if I drew a tangent line here, pause, there we go, a tangent line here, a tangent line here, and a tangent line here. These 1, 2, 3, 4 lines are all going to have different slopes. Okay, these two will be very similar, but they'll still be different. Alright, so now the question is, how do we find the slope given only one point? Well, you can't. Alright, I'm just going to put that out there. You can't. You need 2 points on your graph. Okay, so we're going to use those 2 points, and we're going to use the slope of the secant line to find that out. Now, let's identify this as x, and let's identify this as f of x. Good? Now the point is to find the slope at a particular point. And if we chose these 2 points on our graph, then what we're going to try to find is the point in between. Okay, because if you look, if I drew this, there's your secant line, and if I drew my tangent line through that point, it's going to have the same slope as that secant line, okay, or something very similar. But I don't know what these points are. Okay, I want to choose secant line points that have the exact same slope, but I don't know what those are. Okay, Now on this function it'd be easy to find, but that's not true on every function. So what we have to do is we're going to create, this is, my function's a little messed up here, but this creates a right triangle. So if those 2 points are correct, then this distance here and this distance here should be the same. Okay? So the distance from here to there, we're going to designate as some distance h. So then that means that this x value is going to be x plus h. That means that this y value is going to be f of x plus h. Is that looking familiar? Okay, instead of x, they use h. I just use x. Now, remember, we want to find the slope at a specific point. Okay, well, let's first of all, on your own, go ahead and pause the video. On your own, I want you to try to figure out what the slope of this secant line is. So go ahead and pause the video and try that on your own. And then come back and check. Okay, so the slope of that secant line, remember, it's going to be y minus y, so f of x plus h minus f of x all over x minus x. So it's going to be x plus h minus x. And that simplifies. You notice those x's on the bottom cancel. So that's just f of x plus h minus f of x all over h. This is the slope of secant line. Okay? Now remember, we don't want the slope of the secant line. We want the slope exactly at this point. Alright? Because we don't have those 2 points. We don't have 2 different x values here to work with. We only have one x value to work with. We only have one y value to work with. So, this h, we want to know, okay, this h, okay, we want to bring this in as close to possible, as closely to possible here, and then also as close to possible here, and so that h is approaching 0. So it's the limit as h approaches 0. Now, if you look up here, that's exactly what we have up here. Okay? And this is extremely important. Understand conceptually. If you need to, rewatch the video, try it on your own, whatever, but there's going to be plenty of examples on homework, tests, quizzes to get good practice for this. Okay, and in the future we're going to actually use functions, but it's way better to know how to do this without functions, because I guarantee when this shows up on the AP exam, it's not going to be you find the derivative of a function using the definition of the derivative. Okay, I guarantee you, I promise you, that it's not going to be the case. Okay, you're going to have some general function that you're not going to be able to do anything with. So it's better that you understand it conceptually so you can understand problems like that. Anyway, this is the second video. The next video we will knock out all of the examples.